Compound gears. Compound gears are gears that have the same axle or the same shaft. So C and B are the compound gears here. And that's why we call it compound gear system. And sometimes we're asked to work out the ratio of the system, and you might be asked to work out the speed too, okay, if given one of the speeds. So, we need to look at it simply first, okay, just to make sure that we know our input and output ratios. So we can see there's four gears. We have three axles. So that means two of the gears here are on the same axle. So these ones here are running on this axle here. Okay. And we know that A here is our driver, this one here. So therefore, this is our input ratio that we need to work out. So we work out this ratio here between A and B first. Okay, our input ratio. And that there is driven over driver, as we've seen before. Okay, so this is our driver, the first one with the motor, and this is driven. All right, so that's 10 over 30. 10 over 30. All right, so this is our first calculation here. 10 over 30 gives us 1 is to 3. Okay, 1 over 3, that's our input. And then we look at see what else is meshing. So after our input, we look for our output. And that there is, again, driven over driver. Okay, but we have to think carefully because C is driving D here. Okay, because it's attached to B. All right, so C is next and it's going to drive D. D is the driven. All right, D is 10, C is 20. Okay, so that's 10 driven over driver, 10 divided by 20 will give us a half. And then we have our input ratio multiplied by our output ratio here, which will give us 1 over 6. And that's our ratio. 1 is to 6. So, for example, if A was going at 100 revs per minute, that would be our input speed. What would be our output speed? Well, it's 6 times faster than that. Okay, so therefore D over here is traveling at 600 RPMs. Okay, rotations per minute, 6 times faster. So a very big increase in output speed in that compound gear system there. Now, let's just have another look at calculating the output speed. Okay, so in this system here, we have a motor gear has 28 teeth. Okay, so yeah, that's this one here. It's 28 teeth and it's traveling at 100 revs. So this one here is going around 100 times per minute. The driven gear has 10 teeth. Okay, so it's our output one over here. It's got 10 teeth. What speed is it going? Okay, so again, we get our ratio, all right, which is 10 driven over driver, 10 over 28. And if we break that down, divided by 2's, we will get 5 over 14, okay, which gives us a ratio of 5 is to 14, all right? And just using common sense now, we can say that if our rotational speed is 100 revs per minute, we can divide that by 5, will give us 20. And then we can multiply that by our output of the ratio, which is 14. And there you go, will give us 280 revs per minute. 280 RPM. Okay. So using the same logic of using the ratio to find our output speed, okay, we don't have to learn off any more formula like this one here and still come up with our same answer. So let's look at this question here above. Okay, so in this question here, you're asked in the gear train, System gear A rotates at 160. What is the output speed of C? Okay, so using our formula, driven over driver, we can say that that's 20 driven, 20 divided by 7 driven over driver. So we're basically working out our speed across here, and then we work out our speed from here through here. Okay, so we're going to do it that way, and then get our output speed that way. So it's 20 divided by 7, which gives us a ratio of 20 to 7. And so we get a ratio of our speed. So that's 160 speed in divided by 20 equals 8 multiplied by 7. Our ratio gives us 56. So we have 56 RPMs on our first input gear system here. 56. Now we do the same from B to C. So from B to C, it's driven over driver again. So it's different color. So that's 28. Driven over driver. And when you work that out, break it down, factor it, you will get a ratio of 7:5. So if a ratio of 7 is 56, 5 will be going slower than that. So yeah, there's our 56 from before. Divide that by 7 equals 8, multiplied by 5 equals 40. And that there is the same answer, or RPM. It's the same answer as this question here. Okay, and I find my way is much easier. Stick to what you know, driven over driver. Find your ratio and work out your speeds that way using simple maths. Okay, so I hope you find that helpful.